Hello students, hope you are doing well and hope you have watched the other videos in Get My Classes in this particular topic and other topics as well. In this particular video, we are going to look into the next topic, that is surface tension. Again, it's considered to be a part of properties of matter and fluids. So the concepts that we are going to look into in this topic are cohesive and adhesive forces. We'll look into the intermolecular forces and the two types of intermolecular forces, that are cohesive and adhesive. Then we'll try to define surface tension and see what is the cause of surface tension. And then we'll look into surface energy, and then we'll try to understand the factors which affect surface tension. And then we'll look into an expression for excess pressure inside a spherical surface or in a spherical drop of water. Then we'll define angle of contact, and finally we'll look into capillarity. So to start with, let's try to understand what are intermolecular forces and the two types of intermolecular forces, that are adhesive and cohesive forces. Intermolecular forces are forces between the molecules of a material or multiple materials. So it can be force between the molecules of same material or different materials. So on the basis of this, we have intermolecular forces classified into two categories. One, adhesive forces. Adhesive forces are attractive forces between unlike molecules. So what do I mean by that? It is molecules of two different let's say material. It can be molecules of water and plastic, or molecules of let's say water and something else, iron or whatever. So molecules of two different molecules, the attractive force between the molecules of two different kinds of materials is called adhesive force. Then cohesive force is again a force of attraction between the molecules, but here the force of attraction is between the molecules of same type, that is force of attraction between water molecules or glass molecules or some other molecules. So I hope that's clear. So adhesive forces are intermolecular forces between different types of material, molecules of different types of material, and cohesive forces are intermolecular forces between molecules of same material or same type of material. So once we know adhesive forces and cohesive forces, let's try to understand what is surface tension. So before trying to understand surface tension, let's define a surface. A surface is a common face between two different media, or a common face is also known as interface. So a surface is an interface between two media. In this particular figure, you can see that I have a liquid which seems to be water and air. The common surface or the interface between these two is called surface. So then what is surface tension? Surface tension is the property of a liquid surface to act as a stretched membrane. So it is the property of a liquid surface by which it acts as a stretched membrane. If it acts as a stretched membrane, it gives some reaction. So it causes some force on the objects which are placed on it. So that is what is surface tension. So surface tension, if I have to define it, it is the property of a liquid surface. So I can say it's a property of a liquid surface to act as a stretched membrane. As a stretched membrane. Right? Yeah. Now let's try to understand what causes surface tension. Let me take a molecule which is in the inner part of a liquid. Now I'll take this molecule. I hope you can see this, the molecule at the center. Now you can see that this molecule is surrounded by many molecules, and all molecules are applying force on them, like we have attractive intermolecular forces between them. So because all molecules are applying force in all the directions, the net force acting on it is 0. Now let me look at a molecule which is near the surface. So you see that a molecule which is near the surface, it is only acted by intermolecular forces on the lower part of it. There are no molecules on above it. So there are some unbalanced uncohesive forces acting on it. So let me assume that the surface molecules are like balloons which are tied by strings. Now due to the unbalanced cohesive forces, it's like the strings being pulled closer. So when the strings are pulled closer, what will happen? The molecules on the surface will come closer. So due to this unbalanced cohesive forces, what is the molecules on the surface are closely packed than the molecules in the inner layers. That is, the density of the surface molecules is greater than the density of any inner layer. So, this difference in density of the surface molecules and the molecules of the inner layer is responsible for surface tension. So, I can say the cause of surface tension is unbalanced cohesive forces. So, of course, in general we say unbalanced intermolecular forces, and in particular we say cohesive forces, because only cohesive forces are coming into picture. We do not see any adhesive forces coming into picture here. So, this is what is cause of surface tension. Now, due to surface tension, what happens? As you can see that these surface molecules are always pulled into the surface. The surface tension always tries to minimize the surface area of the surface. So, surface tension, what does it do? It always tries to minimize the surface area of the surface, and because it is trying to minimize the surface area of the surface, it tries to keep the surface in the minimum potential energy state. Now, let us try to get an expression for surface tension. So, how do I get expression for surface tension? So, surface tension can be defined as force acting per unit length of the perimeter of an object. So, what do I mean by that? So, I will take an example of a needle. Let us say I have a needle which is placed in water. Now, this is placed in water. You can assume this to be water. The length of the needle is L. Now, if I take the perimeter of the needle, I can take the perimeter of the needle to be 2L. So, this is the perimeter of the surface. It is the surface between the fluid and the needle. Now, I can say the force, if this is not sinking, the force acting on it is equal to weight. So, force due to surface tension should be equal to weight. Now, force due to surface tension is directly proportional to 2L. 2L is the length of the perimeter. You can neglect the width of the needle when compared to the length, because width is very small compared to the length. So, this says force due to surface tension equal to T into 2L, where T equal to F by 2L is known as surface tension. This is the parameter which gives the measure of surface tension of two objects, or surface tension of a liquid surface. So, the force applied by a liquid surface on an object which is placed on its surface is equal to surface tension into perimeter. I can say force due to surface tension is equal to surface tension into perimeter of the surface. Now, I can generalize this to various situations. Let me take one situation. Let us say I have a circular ring of radius r placed in water. Now, if does not find the force due to surface tension if the surface tension of water is T. Now, surface tension is trying to push it up, surface tension is T, then the force due to surface tension would be equal to surface tension into perimeter. Now, what is the perimeter here? Here I have a surface on the outer part as well as a surface on the inner part. So, the total perimeter would be 2 pi r, that is outer part, plus 2 pi r, that is inner part. So, the force due to surface tension can be written as T into 4 pi r. So, anything, if you take a disc, it will have only one surface. In that case, you can take it as T into 2 pi r. So, whatever object you are looking at, you have to measure the perimeter of the surface and multiply it with the surface tension of the liquid to get the force due to surface tension that particular object is acting or experiencing. Now, let us define surface energy. Now, what is surface energy? Energy required per unit change in area of a surface is known as surface energy. So, what is surface energy? It is energy required, or I will say energy required or energy needed, required for unit change in surface area. Unit change in surface area. This is called surface energy. So, how do I calculate it? Now, let me, in order to find the expression for that, let me find out an expression for work done. Now, let us say I have a surface area. I will take a common example that we have. Let us say I have a soap film, and to the soap film I have a small string that is tight. A force F is acting on this. Now, force mg is acting downwards, which is equal to force F. Now, surface tension is acting upwards. Now, force due to surface tension would be equal to how much? T into 2L. Now, let us say due to this it comes down by a distance x. Now work done equal to force into displacement, that is T into 2L into X. So the total work done or the total potential energy that is stored in this is force into 2L into X. Now work done per unit surface area. What will be the unit change in surface area is what it is? T into 2Lx. 2Lx is the change in surface area by delta A. Delta A is also equal to 2Lx. 2Lx cancels, so I'll be left with T. So surface energy is numerically equal to the surface tension of the liquid surface. Now once I know surface energy, then work done can be calculated as surface energy into change in area. The common questions that we get is what is work required to change the surface area of an air bubble from A to 2A. So what we do, T into 2A minus A is the total work done or the energy required. Now let's look at the factors that affect surface tension. Now surface tension of a liquid depends on the nature of the media in contact with its surface. So it's not necessary that water will have same surface tension with every other object. Water with iron might be something else, water with glass might be something else, water with ebonite might be something else. The next thing is surface tension decreases with increase in temperature. As the temperature of the system or surroundings increases, the effective surface tension decreases. This is due to the decrease in the cohesive forces that are acting, and we know that cohesive forces are responsible for surface tension. Now denser liquids have higher value of surface tension. This is a fact that if the density of the liquid is more, the surface tension will also be more. Electrification decreases surface tension. Again, electrification, like increase in temperature, would result in decrease in cohesive forces, which results in decrease in surface tension. Now contamination of a liquid surface reduces the surface tension. So if there is some other impurity added to the liquid, then the surface tension in the liquid would be less. So if impurities are insoluble or less soluble, if they are highly soluble, then the surface tension increases. So again, you have to remember that if highly soluble impurities are added, then the surface tension of the liquid would increase due to the increase in density. Otherwise, if insoluble impurities are added, then the surface tension would decrease. These are the factors affecting surface. Now let's try to get an expression for excess pressure inside a spherical drop. Now if let me take a spherical drop. If a spherical drop is maintaining its shape, that means there is some pressure which is acting from inside also, because if you know that there is a pressure which is acting from outside which is equal to atmospheric pressure in all the direction. Now there is surface tension which is also trying to squeeze the sphere. Let's say pressure inside is P. Now let me find out the force. If I take the area of cross section as A, then force due to atmospheric pressure plus force due to surface tension should be equal to force due to pressure inside. Now what is force due to atmospheric pressure? I can write atmospheric pressure into, I'll take atmospheric pressure as P naught into pi r square, plus what is force due to surface tension? It is T into 2 pi r, equal to force due to pressure inside is equal to Pi into pi r square. So what is excess pressure? I can say Pi minus P naught, I'll take to one side, I'm taking out pi r square, that is equal to T into 2 pi r. So I'll get rid of pi, I'll get rid of 1 r. So what am I getting? I'm getting Pi minus P naught equal to 2T by r. This is excess pressure inside a spherical drop. Now due to this excess pressure, the spherical surface is maintained, and that's why it's balanced. Now this is what we are talking about is a spherical drop. Now so what we have talked about is a spherical drop. I couldn't continue the same thing. So if it is a hollow sphere, let's say a soap bubble, then the excess pressure, I'll say Pi minus P naught would be equal to 4T by r, because for a hollow sphere there are two surfaces, one outside and one inside. When I say hollow sphere, a soap bubble has a surface of soap film and air outside as well as soap film and air inside. So after that we'll look into angle of contact. So first let's define angle of contact. You can see the figure here. Angle of contact is the angle drawn between the tangent to the surface. See, if you look at the surface here, surface is slightly deformed. So if I draw the tangent to the surface into the liquid and the inner part of the liquid, so this is called angle of contact. So what is angle of contact? Angle of contact is angle between tangent to surface and the part of solid inside liquid. This is what is angle of contact. So tangent to surface of liquid. Now why there is a deformity in the surface of liquid? Now if adhesive forces are greater than cohesive forces, then the force of attraction between the solid placed inside the liquid and the liquid molecules is greater than the cohesive forces or cohesive intermolecular forces of liquid molecules. Due to this, there is a concave surface that is created. Similarly, if cohesive forces are greater than adhesive forces, then the force of attraction between the water molecules or liquid molecules is greater than the force of attraction between the molecules of the solid and liquid. So here this is cohesive forces greater than adhesive forces, and here we have adhesive forces greater than cohesive forces. So depending on that, we get either the surface is like this, a concave surface or a convex surface, something like this. This is the surface here. So let's try to understand that in terms of theta. Now in this case, when adhesive forces are greater than cohesive force, theta is acute. Theta acute means adhesive forces are greater than cohesive forces. And if cohesive forces are greater than adhesive force, theta is greater than 90 degrees or theta is obtuse. If theta equal to 90 degrees, then adhesive forces should be equal to cohesive forces. That actually theoretically true, but we never seen that situation happen. After that, we have something called capillarity. Now capillarity is the rise or fall of liquid level in a tube of small cross section due to surface tension. Now let's see why does this capillarity come into picture. Now let's say I have a surface here, we call this as menicus. This is the liquid surface. Now there is a spherical surface here. That means if I take a point P inside the spherical surface and a point P outside the spherical surface, then P inside excess pressure inside is equal to how much? 2T by R. So excess pressure inside the spherical surface is how much? It is 2T by R. Now if I use Pascal's law, now here atmospheric pressure is there, here also atmospheric pressure is there. Now at this point also the pressure should be atmospheric pressure. Now why the pressure should be atmospheric pressure? Because pressure at the same level is always same. In a static liquid, pressure at a given height is same. So if this is atmospheric pressure and this has higher pressure than this, I'll say this is P1. P1 would be having lower pressure than atmospheric pressure. So I can say P1 equal to PA minus 2T by R. So now let's say this height is H. Now at this point again it is atmospheric pressure. So I can say P1 plus rho GH would be equal to again PA. So from this what I can write? I can write but what is P1 equal to? PA minus 2T by R. So this will give me PA minus 2T by R plus rho GH equal to PA. PA cancels. I'll get rho GH equal to 2T by R, or H is equal to 2T by R rho G. This is the capillarity. Now here I have not considered angle of contact. So if I consider angle of contact, instead of T it becomes T cos theta, because only T cos theta is acting upwards, whereas T sin theta is acting in this direction. So if angle of contact is considered, I'll say if angle of contact is considered, I can say H equal to 2T cos theta by R rho G. This is the height of the height in the capillary tube. This is one way of finding it, but this is the expression that we use. So when a question is asked, make sure whether angle of contact is given or not. If angle of contact is not given, you can directly write 2T by R rho G. But if angle of contact is given, then you have to use 2T cos theta by R rho G. So this is capillarity. This is what is there in about surface tension. So what all things we have seen? We have seen what are intermolecular forces, cohesive and adhesive forces. Then we have tried to define what is surface tension and looked into the causes of surface tension. Then we found an expression for surface force due to surface tension, and then defined what is surface energy. After that, we defined angle of contact and excess pressure inside a water droplet as well as a soap bubble. Soap bubble has surfaces on both sides, so that's why excess pressure would be twice that of a water droplet. And then we moved on to capillarity and got an expression for the capillary rise or dip whenever a tube of small cross section is placed inside a liquid. Hope you could follow this. Thank you very much for watching this video in specific and all other videos of physics and other subjects on Get My Classes. Thank you once again.